Children, let us continue the chapter Introduction to Trigonometry. The exercise 4 is continued. The question number 6. Question number 6. What is that question? Prove that whole root of 1 plus sin A by 1 minus sin A. 1 minus sin A equals secant A plus tan A. Whole root of 1 plus sin A by 1 minus sin A equals secant A plus tan A is to be proved here. Now you consider the LHS. LHS equals whole root of 1 plus sin A by 1 minus sin A. Now here you rationalize the denominator, that is square root of 1 plus sin A by 1 minus sin A multiply both NR and DR, both numerator and denominator by 1 plus sin A by 1 plus sin A. Here it is 1 minus sin A. So you multiply both numerator and denominator by 1 plus sin A by 1 plus sin A. Then you write here multiplying numerator and denominator by 1 plus sin A. Numerator and denominator by 1 plus sin A, that is under the root only. Now that becomes square root of 1 plus sin A into 1 plus sin A whole divided by 1 minus sin A into 1 plus sin A. 1 plus sin A into 1 plus sin A whole divided by 1 minus sin A into 1 plus sin A. Then that is equals to 1 plus sin A into 1 plus sin A is 1 plus sin A whole square, and 1 minus sin A into 1 plus sin A, you can use the identity A minus B into A plus B, that is square of the first term, 1 square minus square of the second term, 1 square minus sin square, that equals whole root. Here 1 plus sin A whole square, you write it as it is, 1 plus sin A whole square, and 1 minus sin square A, 1 minus sin square it is, 1 square minus sin square means 1 minus sin square A. Then again you write 1 plus sin A whole square, and 1 minus sin square A is cos square A. 1 minus sin square A is cos square A. That is, you know that cos square A plus sin square A is cos square A plus sin square A is 1. So cos square A equals 1 minus sin square A. Cos square A equals 1 minus sin square A. Then take the root for both numerator and denominator, that is square root of 1 plus sin A whole square and square root of cos square A. Then square root of 1 plus sin A whole square is 1 plus sin A, and square root of cos square A is cos A. Cos A, that equals, here you separate 1 and sin A, 1 by cos A, 1 by cos A plus sin A by cos A. 1 by cos A plus sin A by cos A. 1 by cos A is, that that is secant A. Secant A, and sin by cos is tan. You got secant A plus tan A, which is equals to RHS. So you proved that. Therefore, whole root 1 plus sin A by 1 minus sin A, 1 plus sin A by 1 minus sin A equals secant A plus tan A. Secant A plus tan A. Now the seventh one. What is that seventh? Prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equals tan theta. Now you consider the LHS. LHS equals sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. That equals, here sin theta is there, here sin cube is there. So you can remove sin theta as a common sin theta. In the bracket you are going to get, as sin theta is outside, you will get 1 here, minus 2 sin cube theta means sin theta is outside, 2 sin square theta. Here 2 cos cube theta, cos theta is there. So you can remove cos theta outside, and what is remaining in the bracket? Here 2 is remaining, and cos cube theta, cos theta is outside means what is remaining here? Cos square theta minus cos is outside, so you will get 1 here. Then sin theta, then you write 1 is, you know that 1 is here sin square theta plus cos square theta, or cos square theta plus sin square theta, cos square theta plus sin square theta minus 2 sin square theta, that divided by cos theta into 2 cos square theta is there. You write it as it is, 2 cos square theta minus 1 means 1 is, again you write cos square theta plus sin square theta. Here this is 1. You know that cos square theta plus sin square theta is 1. Then you write sin theta by cos theta, and cos square theta is remaining, and sin square theta minus 2 sin square theta means minus sin square theta is remaining here, and open the bracket, 2 cos square theta minus cos square theta minus sin square theta, and sin theta by cos theta, you write sin theta by cos theta, and here you are going to get in the numerator cos theta minus cos square theta minus sin square theta, that divided by 2 cos square theta minus cos square theta, you are going to get cos square theta minus sin square theta. Then you know that cos square theta minus sin square theta, cos square theta minus sin square theta cancels. Then sin theta by cos theta is tan theta. Sin theta by cos theta is tan theta. So that is equals to RHS. You got the RHS. So you write, therefore sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equals tan theta you got. Then the eighth question, prove that sin A plus cosec A whole square plus cos A plus sec A whole square equals 7 plus tan square A plus cot square A is to be proved here. What you have to prove? Prove that sin A plus cosec A whole square plus cos A plus secant A whole square equals 7 plus tan square A plus cot square A. Now you consider the LHS. LHS equals sin A plus cosec A whole square. Sin A plus cosec A whole square plus cos A plus secant A whole square. Then you expand it. What is the expansion of sin A plus cosec A whole square? Here we have to use the identity x plus y the whole square equals x square plus y square plus 2xy. So expand it, sin square A plus cosec square A plus 2 sin A into cosec A plus expansion of cos A plus secant A whole square, that is cos square A plus secant square A plus 2 cos into sec. So you take 2 into cos A into secant A. Here you use the identities used. Which identity used here? X plus y the whole square equals x square plus y square plus 2xy, or in other words you can say a plus b the whole square equals a square plus b square plus 2ab. Then here you take sin square plus cos square together. You take these two together. So you write sin square A plus cos square A. These two you have taken together. Next you take cosec and sec together plus cosec square A plus secant square A plus 2 sin A into cos A, 2 cos A into sec A you take. 2 sin A into cosec A plus 2 cos A into secant A. Then that equals, you know that sin square A plus cos square A is 1 you write, plus cosec square A. 1 plus cot square A is cosec square A. So in the place of cosec square A you write 1 plus cot square A plus secant square, also you know the identity is 1 plus tan square A plus you write 2 sin A, and cosec is also 1 by sin A plus 2 cos A, secant A is also 1 by cos A. Here you use this one and this one. How you got it? Here you write cosec square A equals 1 plus cot square A, and secant square A equals 1 plus tan square A, and cosec A equals 1 by sin A, and secant A equals 1 by cos A. This much is used in this step. Here how you got 1 plus cot square A, that is cosec square A is equals to 1 by cot square A. And how you got 1 plus tan square A, that is secant square is equals to 1 plus tan square A. And also you got here 1 by sin A is cosec A, and 1 by cos A is that is secant A. Now you write here 1 plus 1 plus 1. 1 plus 1 plus 1 you write 3 plus again here sin A cancels, you write 2 and cos A cos K cancels, that is also 2 plus you write these two together, that is cot square A plus tan square A. Here these three taken together as a sum and sin A cancelled. What is remaining here? 2 and here cos A cancels. So what is remaining here? 2 is remaining. So you got 2 plus 2 here and here cot square A is taken and here tan square A is taken. Now here what is the sum of 3 plus 2 plus 2? That is 7 plus cot square A plus tan square A, that is equals to RHS you got. Therefore what you proved here? You proved that therefore sin A plus cosec A whole square plus cos A plus secant A whole square equals 7 plus tan square A plus cot square A. Tan square A plus cot square A. In this way you got the proof. Next you take the 9th question. What is that question? Prove that cosec A minus sin A into secant A minus cos A equals 1 by tan A plus cot A. What do you have to prove here? Here we have to prove that cosec A minus sin A into secant A minus cos A equals 1 by tan A plus cot A. Now you consider the LHS. LHS equals cosec A minus sin A into secant A minus cos A. Then you express cosec A in terms of sin. You know that cosec A is the reciprocal of sin. So you write cosec A is 1 by sin A minus sin A. So cosec A is 1 by sin A minus sin A into, here secant A is the reciprocal of cos. So you write secant A is nothing but 1 by cos A minus cos A. Now you take the LCM. So what is the LCM here? LCM is sin A. Then the numerator becomes sin A into 1 is sin, 1 into 1 minus 1 into sin A. Here if you consider 1 is there, 1 into sin A you will get. So you will get sin A into sin A, sin square A. Then you take cos A. Then in the numerator 1 minus cos square A. 1 minus cos square A. You know that 1 minus sin square A is cos square A. By sin A you write sin A only into 1 minus cos square A is sin square A. And you write cos A only. Here you write cos square A plus sin square A equals 1. Therefore, here cos square A equals 1 minus sin square A and sin square A equals 1 minus cos square A. Then here cos square A is there. So you write cos square is cos A into cos A. Sin A is sin A into sin A. That divided by sin A into cos A. Sin A into cos A. So you can cancel sin A and also cos A cos A. Then you will get here sin A cos A. You will get cos A sin A. You get what? Cos A sin A, right? Cos A sin A. Then here you write, here you consider, that is sin A into cos A by 1. You take it is 1 here. Then here you write sin A into cos A. That 1 means you write sin square A plus cos square A. In the place of 1 you can write sin square A plus cos square A, and you know that the value of sin square A plus cos square A is 1. Now you divide both numerator and denominator by sin A cos A. So you write sin A cos A by sin A cos A, and also sin square A plus cos square A by sin A cos A. What you have done here? Dividing numerator and denominator by sin A cos A. Sin A cos A. And also here you write 1 equals, what you have taken, sin square A plus cos square A for the previous step. Now you write, this cancels 1 by, you will get sin square A by sin A into cos A, separate the terms here, plus cos square A by sin A into cos A. Sin A into cos A, that equals 1 by, that equals, you write 1 by, that is sin square A means sin A into sin A by sin A into cos A, plus cos square A means cos A into cos A by sin A into cos A. That equals, here sin A cancels, sin by cos. Sin by cos is tan, you know. So write 1 by tan A plus, here you know that cos A cancels, cos A by sin A. Cos A by sin A is cot A. So you got that 1 by tan A plus cot A, that is nothing but RHS. That equals RHS. So you got that. Therefore cosec A minus sin A into secant A minus cosine A equals 1 by tan A plus cot A. Then the 10th question, that is last question, prove that 1 plus tan square A by 1 plus cot square A equals 1 minus tan A whole square by you take that is, what is that, 1 minus tan A by 1 minus cot A whole square and equals tan square A. So what do you have to prove? 1 plus tan square A by 1 plus cot square A equals 1 minus tan A by 1 minus cot A whole square, that equals tan square A is to be proved here. Now you take this first one. So you take, consider consider 1 plus tan square A by 1 plus cot square A. 1 plus tan square A by 1 plus cot square A, that equals, you write the numerator 1 plus tan square A as it is, 1 plus tan square A by 1 plus 1 by tan square, 1 plus 1 by tan square A. You know that cot equals, because you write cot A equals 1 by tan A. Cot A equals 1 by tan A. Then that equals, write 1 plus tan square A as it is. In the denominator you take the LCM. What is the LCM here? LCM is tan square A, and the numerator becomes tan square A plus 1. Tan square A plus 1, that equals 1 plus tan square A by, this also you can write 1 plus tan square A by tan square A. Then here you write 1 plus tan square A into the reciprocal of this one. So you write that is tan square A by 1 plus tan square A, and this 1 plus tan square A, 1 plus tan square A wholly cancels here. What is remaining? That is tan square A. Consider this is the first. So you consider this is the first. Again you take the next part. What is that next part? This one. 1 minus tan A by 1 minus cot A whole square. Consider 1 minus tan A by 1 minus cot A whole square. Here also you convert cot A in terms of tan A. Write 1 minus tan A by 1 minus 1 by cot A whole square. Whole square, that equals here you take 1 minus tan A whole square, that divided by, here you write this is 1 minus tan A, not cot A, 1 minus tan A, because cot is equals to 1 by tan. Then you write this becomes tan A minus 1 by tan A whole square, and that equals, you can write 1 minus tan A whole square by tan A minus 1 whole square, also by tan square A. And then also you can write 1 minus tan A whole square by, this also you can write here tan A minus 1 whole square and 1 minus tan A whole square, both are same. So you can write it as 1 minus tan A whole square, or you can write this is whole square by tan square A. If minus is removed outside, otherwise you can exchange it directly, both become same here. Then you write 1 minus tan A whole square by 1 minus tan A whole square by tan square A. That equals, you write 1 minus tan A whole square, take the reciprocal here, that equals tan square A by 1 minus tan A whole square. These two cancels, you will get tan square A. Consider this is the second. So first also you got tan square A. First also you got tan square A, and second also you got tan square A. Therefore you can write that, therefore from first and second, first and second, you write 1 plus tan square A by 1 plus cos square A equals 1 minus tan A by 1 minus cot A whole square. Both are equals to tan square A. Both are equals to tan square A. The chapter is completed here, and you must practice the trigonometric problems.